interesting because it is a need of the time. The topic is hydrogen fuel cell. You are aware of using solar cells for fuel cell for various applications, and the fuel cells are different principles. This is the today's our discussion is on hydrogen fuel cell. This is it will be developed and with the efforts by Upendra Paluri, who is MSc from ISC Bangalore, and he has a professional experience of 22 years and more. He has worked with Tata Motors, Reva Electric, Daimler, and two more automobile industries. He has developed, he has a group of people has developed a fuel cell, particularly working on hydrogen. Right now, their project is for 6 or 12 volt, but in the future, they are going to develop fuel cell of larger capacity in terms of kilowatt, and that is the point where we are going to discuss what is the principle, what way we can help the technology to develop, and all these things he will discuss in his discussion. Now I request Upendra to start the discussion.
Good morning, everyone.
Everybody is audible?
I am audible?
Yes, please continue, sir.
Yeah. Thanks. Good morning, everyone. And thanks, Dr. Pramod ji, for a nice introduction and giving me an opportunity to present our technology. So today's topic is I am representing Luxusfur India Private Limited, and it is the brainchild. It is the brainchild of Dr. Mr. Pankaj Kumar, and he is the founder of this company. And I'll give a brief introduction how he has started and what is his vision and all, so that it will become a relevant. He has worked in many. He has got more than 25 years of experience, and he is the principal architect of the first hydrogen commercially available hydrogen fuel cell in the earlier company. Okay, and he has got many patents and many papers also he has published it. And also he's the one pioneer in the dual. So he has got a lot of vision in this, and he started this company 3 years back, and developing different. So what is the areas we have to work on it? So based on that, this company has formed, and I will throw more light on this one. What is the vision? And where we are going to do next 5 years down the line, and like that, and what are the applications and all. Hope are able to see me now.
Hope recording it started.
Okay.
Yes, you are seeing.
Yeah.
Please continue.
Okay. So yeah,
Recording it started.
yeah, yes, sir. Yeah. So the brief agenda of for this today's is hydrogen. What is everyone is hydrogen is an essential hydrogen, and what is the company vision and the team behind this, and what is our fuel cell vision, and current status of what is the current design, and what are the applications. And I will come out with a one application, which is application related to drone, and where we stand right now, and what is the plan, next strategic plan in next 5 years down the line, and what is our go to market strategy. And if time permits, I'll go for competition and sensitivity analysis. That is what is the brief uh, presentation. Yeah. Hello, are you able to see the screen, no? So hydrogen is essential. It is an essential commodity right now. So if you see right now, the fertilizer industry is using the hydrogen in the form of ammonia. It is more or less, it has been invented long back, and hydrogen is formed used nitrogen and hydrogen is mixed, and in the form of ammonia it is passed on to the as a form of urea to the plants. Otherwise it is a very good invention, and otherwise we lot of starvation people have died because of starvation, this ammonia has been invented during 1930s and all. So 55% is already consumed in the form of hydrogen is formed in the head. And similarly, refinery industry is using 25%. I'm not going detail into it, but I'll just give an overview where we stand right now and what is the importance of hydrogen and what is the clear pathway and what how we are going to go. And by chemical industries also they are using, and even steel plant is also using hydrogen, right? And around in globally 10 100 mmt consumption of hydrogen is produced using natural gas as well as coal. So this is the total in India itself, 70 mmt is used. Okay, so the hydrogen is broadly classified into four categories, depending on the how it is produced. Yeah, hydrogen which is produced using fossil fuels, that is gray hydrogen. Mostly it is 49%, the majority, and other one is blue hydrogen and brown hydrogen, which is produced. Hydrogen is produced using coal. That is what brown hydrogen. The focus is now green hydrogen, which is produced using electrolysis and renewable energy and using biomass also now right now. Yeah, so that is what is that our focus is that all the refinery industries and should be converted into means if once the hydrogen is produced, the fossil fuels will be converted into shifted to the hydrogen, so that whatever 4% is there and 25%, this will be means 15%, 40%, and of around 44%, 42% will be gone into the renewable energy. That is what is the target. So presently the hydrogen cost um, is around $4 right now. Started with $6, now presently $4, and in 2026 it will be $2, and $1 it is planning to come by 2031. Yeah, so it is driven by a Department of Energy, US government, and they have given a vision that it should be become in 2021. It has been hydrogen policy has been um, declared that $1 1 decade in 1 kg hydrogen will cost $1. Immediately, our Mukesh Ambani has released a that we will give the 1 kg of hydrogen by 75 rupees during that time. Okay, so that is the vision. So vision is that yes, now presently we are fossil fuel. Now we are using gray hydrogen, blue hydrogen, and biohydrogen also using biomass, and further we are going for a green hydrogen. That is the pathway. So using this is what is the future. Once it has become $2 per kilowatt, yeah, $2 per kilowatt, it will be commercially viable, because if you compare the fuel cost presently, if it is 2026 $2, if you consider, it will be around 40 rupees, 40 per kilowatt. Even CNG also it will be around 28 rupees, and electricity it will be lesser than electricity. This hydrogen using hydrogen cost is available at $2, then it will be less than the electricity cost. It will be the cheapest fuel post 2026. So that is what we are targeting by 2026. $1 it will become a 130. So India is also not lagging behind. We are also so for that hydrogen mission. Recently, Government of India has released it, and lot of bigger players like Adani, Ambani, means Reliance, L&T, all major players, even all public sector companies like IOCL and all, they are coming up with a bigger green hydrogen plants, right? And because they have to shift very quickly to the from fossil fuel to hydrogen. So this is one thing, and so we should not lag behind in this green hydrogen production. So our sorry. So we are not lagging behind this. So if you are our vision, company vision is that there are anthropogenic emissions are there. which is a widely accepted norms, right? Concern, because you can see lot of global warming is there, and environmental pollution. And if you can see the fog really in Delhi right now, it is you cannot breathe a normal air in the month between October to December. So these are all due to emissions generated by human activities only. So we need to call for an urgent solution. Now, urgent solution, we have to cure this problem as soon as possible. So for that reason, we are developing. This company has been Luxusfur is established by Pankaj Kumar, and in 2021 that we want to develop this indigenous solution research and development in using for futuristic technologies. In this core technologies, we want to work in different areas using hydrogen fuel cell. Hello?
No, yeah,
Yeah, you're able to hear, no? Yeah.
yeah, you're audible.
Next 5 years, what is our focus is that we want to, next 10 years, we'll definitely want to become a hydrogen, part of the hydrogen generation, distribution and all. But our next 5 years focus is into the consumption of hydrogen. Once the hydrogen is there, how it can be utilized, and and various appliances. What are the applications we are targeting right now? The first target is UAV drone, agricultural drone, and utility drones, as well as other medical devices, medical drones also in cargo. So different drones we are targeting right now, but that is the needy application right now. And similarly, we are also working for a power backup devices. That is also a need of the hour, but that is later point of time, 2025 onwards. Our target is UAV drone and commercial vehicle. Now commercial vehicles like Tata Ace kind of vehicle is there, and that is to electric vehicle is there, that has got little bit problem. Yeah, that also I will throw some light on that. In what way fuel cell will add to the commercial vehicle segment. And agri tractor is there, the 16 HP tractor, 25 HP tractor, where these tractors require continuous energy of source. So using a battery is there, but it is a limited application. There we have to work with the fuel cell, so that it can run for a continuously, even forklift also. And similarly off-road vehicles, like bigger tractors and JCBs and all. And coming to later on, once everything is proven, we'll go into the passenger vehicle, buses, and two-wheelers and three-wheelers, cars will be coming into the later point of time. And similarly, we are also working on indigenization of components. So Mr. Deshpande has thrown light that yes, we are working on the, because in the next couple of years, all these components, whatever going into the fuel cell system, they are majority are imported, like BOP components. But core reactor we are developing in house. Yeah, those components we are targeting right now, and indigenization with collaborating with different institutions like IIT Bombay, IIC Bangalore, and COIP. Like that, we are tying up with different components. We have different ideas are there, and those ideas we want to collaborate with the industry veterans and institutions to localize these components. So that I will throw light on this how we want to go ahead in the next couple of years. So I have explained about this one. This is the founding team. So this is the Luxusfur is a research organization. It is a consortium of veteran scientists and engineers in the field of electrochemistry, even mechanical engineering, metallurgy, vehicle engineering, and electrical and electronics, and 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 IT also. So we are a consortium of, and it is led by Pankaj Kumar, and he is a principal architect, and he worked in major industries, Volvo, Eicher, Parametric, JSW, and KPIT Technologies. And I explained you this. He has developed the first dual phase steel at earlier company, and he's the principal architect at commercial hydrogen. Yeah. So I So what is our vision? So our vision is that fuel cell is nothing but a chemical reactor. One side hydrogen will be supplied and other side oxygen, and both will react, and electricity will be generated. And this is a chemical reaction, and HFC is nothing but a chemical energy which is converted hydrogen into a into chemical energy, and and have byproducts are hydrogen and water are the byproducts. Electricity and heat and water are the electricity is the main generator, and byproducts are heat and water. Yeah. So if you see this picture, na, so we are targeting right now 20 kilowatt, 40 kilowatt, and 120 kilowatt in this year. We are targeting 20 kilowatt, and this year and the next year, and the subsequent year so 40 kilowatt and 120 kilowatt. In the similar way, we are targeting actually localization of components. 23, 24, we want to target 40% of the localization of BOP system, and 24 70%, and around 100% we want to next couple, because if you see we want to control the process raw materials which is going into the fuel cell, so that the cost we can bring into the control. So for this reaction, we want to collaborate with many different institutes. For this year, we are already we have pool of Indian suppliers. Yeah, we right now all the BOP components, right? Majority components of BOP components are like sensors, like compressors, and humidifier. I'll show you the components also. And those components right now, they are nobody is there to supply for this kind of 20 kilowatt stack. No compressor is developed by in India. So that's why we have to import it. It is a very exorbitant cost right now. So to bring the control of the fuel cell cost, we have to localize all these plants. So that is the reason we have strategized that yes, we are targeting the high value items right now, and slowly we will go into the next level to control the cost. So first, right now, that for that reason we have collaborated with IIT Bombay for compressor localization, and and the once the design is completed, design will be ours, and under the guidance of IIT Bombay, design development and product development will be done, and simulations, everything will be done, and then we will give the entire technology to a manufacturing partner for mass manufacturing of that compressor. And similarly, we are also targeting for compressor, and also next year we are right now we are fuel cell stack is developed indigenously and made in Pune. That is also, and we want to go with a fuel cell stack with a graphite place. It should be low weight, and thermal conductivity will be good and low weight. So whatever present weight is there, it will be lesser than that one. So we want to first is that low weight and volume and low cost also. That is what is the target by 2026. We want to 24. We want to target that it should achieve the cost also. So for that reason, and also we want to lot of composite materials we are planning, and our design is such a that there are no fasteners are used in this design. Right now, our focus is fasteners design in the present design itself. So we are achieving this 40% in this year. That is what we are achieving. And next year, we are planning to bipolar plate with ultra lightweight carbon composite like graphite, and also and a gasketless design. Right now, gaskets are there. That gaskets also we want to eliminate right now. And later point of time, we want to develop our own membrane. So with that, or down the line, we want to achieve this. We using the membrane also. We are collaborating with IIT Madras, and ISC Bangalore for membrane development. And so these talks are going on to what are the areas we want to collaborate, and which area we want to localize first, and this one. So if you see this one, how where we stand per energy per kilowatt. If the process raw material we are bringing in control less than by 2026, it will be competing with the IC engine cost. Presently, it is competing with Luxusfur. Presently, it is a PEM cell. It is competing with battery. But we have to compete with IC engine cost. So that is our target. So for that reason, we have right now PEM cell we are using. It is around 40 to 60% electrical efficiency. Cost is high right now, and cost control also is partial right now because we are dependent on imports only, and tech control also partial. Okay, AEM fuel cell also, that is also 60 to 70% electrical efficiency. Cost is high right now, and cost control also this one. So we want to develop our own membrane. With that, electrical efficiency is higher, cost is also within our control, and technology also will be in control, so that we can compete with in IC engine cost in 2 to 3 years down the line. So if you see this one, this is our fuel cell stack. Luxusfur means it is stack is around 300 by 100, and 1.5 is the thickness, right? And these are the hydrogen port, and this is the oxygen port, if you see, right? And this is a monopolar plate, and these two cells will be welded, actually laser welded, joined together, and one side this membrane will be there. MEA will be attached, and like that we will be attaching the stacks like this. If you see right side, if you stack it, this in a 6 kilowatt stack, around 40 cells will be stacked together, and that will be packaged in a packaged here with a BOP system with hydrogen compressor, all systems, and this system will be packaged in a drone. This has been designed for drone application. Okay, so this design is a generic design, and we can scale it up to 120 kilowatts. That is what we have targeted, 40 kilowatt this year, and then next 80 kilowatt and 120 kilowatts is the target, actually. 20, 40, and 120 kilowatts right now. So this is what we are. It's a common design for AEM and PEM cell, and we are developing a smart cooling system. And for this, there are a lot of ECUs, control systems are developed. We are developing it, and this is what is the plan. And advantage is that it is economical and low cost. We want to bring it down to the as low as possible, matching to this one, and it is compliant to the whatever cylinders and all. This is compliant to the AS 157 norms. Okay, so if you have a question, where is the applications right now we are targeting right now? So for that, we are depending on availability of hydrogen and energy to power ratio, EPR. If it is more than one, right? Like these are all energy intense device, like forklifts, tractors, drones, power genset applications, and JCBs, and big tractors and all. These people, they energy hydrogen is can be available at captive centers, actually. Hydrogen plant can be set up at a warehouse for a forklift kind of thing. It has to operated in a closed premises. There should not be any noise and all. The hydrogen plant can be available at captive center, and that hydrogen we can use it for running this forklifts, tractors, even drones, and power backup devices, right? So presently it is around 330 to 400 rupees is the per kg watt, and with that we have considered 22 rupees is the per kilowatt hydrogen availability. Yeah, is the cost it will charge. Similarly, maybe $3 it will happen. If that is there, it will happen in 2025. 18 rupees is the per kilowatt it will happen, and then we can move on to the big JCBs, cranes, and all, so that it can move from small vehicles to bigger forklifts. Similarly, by 2026, we want to see that energy intense devices where energy power ratio is less than 1, where energy is also required, power is also required, where running the suppose a car is there, they require more power. you have to cover the acceleration 0 to 100 in a very few seconds, 3 seconds or less than 5 seconds. In that case, it requires, it has to collaborate, means the power source should be very available at a very optimum cost, so that this can be commercially available. So 2026 we are targeting that buses and boats, big boats and trains will be there, so that 15 kilowatt this can be commercial. By 2027, yeah, we target that yes, it will become 10 rupees per kilowatt. Then we can go for three wheelers, four wheelers, trucks and all other applications. Okay, so coming to drone, I'm focusing right now. Why we have, out of all these applications, if you see, we have focused right now on working on a drone application right now, because why that is, drone is most needy application, and where the present power pack is having a lot of issues are there, right? So if you see the underwater defense vehicles, underwater and UAV drones, yeah, immediate application. So the present battery, lipo battery and lithium battery is that they are having a limited, um, they having a limited cycle time. And the suppose a drone is there, agricultural drone, it is operating only in a lipo battery hardly 8 to 10 minutes, and the life of the battery is lipo batteries hardly 300 to 400 cycles. 300 cycles you can assume, right now for this one. So to cover a 1 acre land, to means a decent land, it has to every 10 minutes it has to come back for swapping, battery swapping. And then and also continuously the farmer is, even drone is not getting operated. So lot of failures because of limited cycles. The drone is not operable, not more than 6 months maximum, 3 months. If they are operating continuously, not more than 3 months to 4 months, they are able to operate continuously. So that the productivity of the productivity is of the farmer who was it operating, like aggregator is there, who is running this no, drone operator for pesticide, spraying the first pesticide, it is hampered actually. So for that reason we have targeted this drone application initially. And presently I will so that why, what is the USP is, it is lightweight, longer range, and it has got a high flight time. I will come to the subsequent and indigenous. Okay. And underwater also same thing. And defense also, they are looking for a good solution, where it can have a longer flight time. And it a longer flight time so that it can go deep into the enemy territory and bombard the flights and come back. That is what is the even defense is looking after. And utility like firefighting equipment is there. And suppose at 15th floor, some some urgent thing is to be sent. So now using drone, we can extinguish the fire at 15th floor by developing a small fire extinguisher, so that we can supply there and spray. We can extinguish the fire at 15th floor using the drone. That is what is the target actually. Hello,
Hello, everybody is audible?
hello.
Everybody is audible?
Yes, it's audible.
Yeah.
Thank you.
Okay. So coming to why we have chosen the drone as best one, because um, it is because we are the only company which will be using the closed cathode fuel cell. Right now, fuel cells are available in, hello, yeah. So it is having a high flight time, high endurance.
Please, please close your audio. Participants are requested to close the audio. You continue.
Yeah. So coming to why we are using chosen the fuels drone as the first application is that It requires because it has got high endurance life, flight time, high payload ratio is also very important. And what is the output is electricity and heat. And once the drone application is used for agricultural purpose, you can use it as a portable genset. Once regular work is over, you can charge the you can use it as a power gen set application. Just fill the hydrogen and you can power the pump or any agricultural device. Okay, so main USP of this is low power rating, free heat and water, and endurance life is more than 20 hours. We are giving a 20 hours of life, and efficient and compact. And so if you see this graph, right? Suppose we see that 0 to the drones are available from 2 kg, 10 kg, 25 kg, and 50 kg, and 150, and around 2 ton. If you see bigger players like 2 ton and helicopters and bigger aeroplanes are happy with the aviation fuel right now, right? And the smaller drones, 2 kg up to 5 kg, 10 kg drones, they are also happy with the lipo batteries because they can operate, and they are happy with that. But the problem is coming between 10 kg to 250 kg drones. They are suffering from the lipo battery because there is no power source to power them for because the flight time is very less and cycles are also less. That area we want to focus. See, if you see this graph, the lipo battery less than 25 kg fuel cell also both will match. Fuel cell will weigh around 10 kgs, whereas lipo battery is also weighing around 11 kg. But if you want the flight time from 25 minutes to 50 minutes, it has to double. Lipo battery will be double the battery. It will take around 16 kg, whereas fuel cell will take only incremental. It will take 1.2 or 1.3 kg. That's all. 12 kg within that 50 kg drone. So, and also if you go beyond 100%, 100 kg, the fuel cell will weigh around 15 kg only, whereas lipo battery will weigh around 60 kg. So that is the scale we have to operate. So our focus is between 50 to 125 starting, and develop all these 25, 50, 75, 100 up to 250 in the increment of 25 kg. All drones will be developed. So if you compare cycle to cycle, na, suppose a 25 kg drone is there, you want to operate for half an hour. So for a hypothetical case, and the present lipo battery is costing around 75,000 right now, right? And if you want a lipo battery to be operated for 30 minutes, you require 3 sets of battery. That is costing around 2.1 lakh, right? And whereas fuel cell is costing around 8 lakhs only. We are charging for 6 kilowatt stack right now 8 lakhs per. Life of the fuel cell is 20,000 hours. That is around 40,000 cycles we will be getting it. Whereas lipo battery for consideration 400 cycles only we are taken. So for lipo battery to match to the fuel cell cycles of 40,000, it requires more than 2 crores. 2 lakh 2 lakhs if you say, and if you want to run for 40,000 cycles, it requires 2 cycles, whereas fuel cell will require only 8 lakh rupees. So per cycle amortization cost, if you say, it will be 500 rupees for a lipo battery, whereas fuel cell will be 20 rupees. That is the cost difference. Hope so. If any queries are there, I can answer any point of time.
We'll
Hello?
have at the end.
Yeah, that's fine. So
You can
this is what
complete
is
with your
yeah, I'll
part.
complete it. Yes, correct. So this is what is the UAV drone we have targeted, and I will show you the what is the status of present status also, and then we can move forward. Right. The similarly applications are tractors also. This is also fuel cell equipment like small tractors and all the equipments like tillers and all can be converted into fuel cell operated. Okay, once the hydrogen is available, we'll move towards that area, right? And also we are targeting genset applications right now, where because suppose if you see a genset applications running a mall, right? It is a very bulky as well as noisy, and to run a mall, it requires a very big genset, right? And the cost is very high. If you see that over a period of time, we would like to replace with our hydrogen fuel cell later point of time. So, and also the pure water is coming, which is in the form of a distilled water, which can be used for other purpose also, heat and water. Other application is a forklift, where forklift is also a needy application, where it has to come now in the warehouse. The forklifts are to be operated in a silent. So presently, all the forklifts are converted into electric using a lead acid battery right now. So what is the problem is lead acid batteries are that now the operating lead acid batteries having they have to charge for 8 hours, and it has to cool for 8 hours and run for only one shift, 8 hours only. So that the productivity from the lead acid battery is only 8 hours only. Whereas fuel cell, you fill the hydrogen and you can run the complete, that is what lead acid is only 8 hours only, one shift. Whereas fuel cell, we can run it for 3 shifts. And the cost is also very less comparative to the battery and CNG per shift we are targeted. This is what we are planning to move for forklift operation also. So product development plan, that's what I target 22, 23. We are targeting many applications, and like design, development. We are in this development phase. Testing, we are going, and certification and piloting for different applications. We are forming actually. So right now, 20 kilowatt stack we are developed, and we are going for testing equipment. So, and also we have a plan that once the hydrogen is available, and we want to be a biohydrogen village also, we are planning. Suppose we are tying up with the IIC Bangalore, because they have generated the biohydrogen mass. At a lab level, they have done it now. That we'll be taking up, and we'll adopt one village, and that technology, using that technology, we would like to generate the biohydrogen, and from biomass hydrogen will be generated, and that hydrogen will be run the tractor and agri equipments what I showed you. All these things will be run using that one. So we'd like to play a pivotal role in this one. And once the hydrogen is available, we'll tie up with PISO agencies, and to run different biomass plants, and we will like to collaborate with different like agri tractor manufacturers, and deploy this agri equipment differ for the different villages. One model will work out, and similarly we'll move on to the different village. So in this way, the hydrogen village, it can be self sufficient. They need not depend on public fossil fuel, as well as on also, as well as other gases also, right? So that they can use this hydrogen. Using hydrogen, they can operate all these village equipments and move forward actually. This is what we want to become, a green village, hydrogen village in our future plan, and we will want to create a social cause by creating this village over a period of time. So what is our go to market strategy is that, yes, we are collaborating with our application partner. Suppose a tractor is there, we will be developing the fuel cell tractor, and our partner is there, he will be doing the vehicle engineering part, and deploy this one in a village, and run it, and move forward. That is what is the, and we are also tying up with different applicationer partner, like tractor, and forklifts. Different partners we are looking for, so that we can JV will be formed, and the product development cycle can be followed. So this is the competition slide. I'm going, right. So these are all the competitions. 10-15 companies are there who are doing this. We will be among them in next 2 to 3 years down the line. So okay, so if you see this sensitivity analysis we have done it. What is the effect of hydrogen availability, fuel cell cost, weight and volume, right? Reliability. If you see that hydrogen cost presently it is 400 right now, right? And the revenue for, if you were not reducing the hydrogen cost, the volume per revenue per volume will be very less only. If you are reducing to 100 kg, it will go to 50,000 k. That is what is the revenue. It is affected actually. This is what more emphasize. Hydrogen cost is more important, and like that hydrogen availability also. If hydrogen is available in biohydrogen, we can go ahead. If it is available all over, we can generate the revenue very well. If it is available only in a limited edition, will also be limited. So fuel cell cost also presently it is 2 lakh rupees right now. We are targeting the then the revenue will be limited. But if you are reducing to 50,000 per kilowatt, next 2 to 3 years down the line, we will be having the revenue around 50k once the fuel cell cost is reduced to 50,000 k. So this is our target actually. And weight also we want to reduce 5 kilowatt per kg. This we want to reduce it to 2 kilowatt. That is what one is. And reliability also, what we are right now is 5,000 hours. That's what our target is, 20,000 hours. So that it will compete with the fuel cell engine. In reliability, we are not competing with engine because it is more than 1 lakh or 60 to 1 lakh cycles. But cost and performance wise, everything we want to compete for. But battery in the from the battery point of view, yes, we want to battery cost. If it is right, sorry, battery cost is around 16 to 18k right now, and the specific energy is 240 250 watt hour per kg. Yeah, similarly, if that is the case, we want to reduce it. The battery cost is 7,000 and 4,000. It will be our we are competing with battery definitely. If this is cost is high, low, as well as this one, our volume will be reduced. So if it is 16k and 250k, our volume will be more. So we are assuming that it will be between 13k to 15k, so that it will both battery technology and hydrogen fuel cell technology coexist. So this is what is the strengths, and we SWOT analysis also we have done it. So what are the strengths? We are innovative. We are tried and trusted, and hands-on experience, because we are collaborated with industry veterans who has already done, and lean and we want to be a lean and low cost work culture, and network of domain experts. And weakness is, yes, where time is the main critical thing. Infrastructure, we are dependent on government policies, and academic institution support, and government support, right? And opportunities, yes, we will be the first company in hydrogen fuel cell closed cathode drone, and we are looking for that. We should be the first company in this world, and we have high potential. Valuation is there. Yeah. And battery is the limitations, and threats are that, yes, lack of hydrogen retail distribution, components availability, financial strength. Those are all we want to convert this into a different opportunities. Yes, product development, we were developing these strengths. Where our opportunities are, we are converting into strengths actually. So we have a common architecture for different applications, and we are achieving the durability, and we have targets to run this program in a very efficient way. And we whatever institutions, we are thinking that, yes, we are collaborating with different institutions, so that we can go research institutes, even industries, and different we can collaborate, so that consortium, we can develop this mechanism will be developing it soon, and so that we can develop this low cost solution, right? And threats also, this is what is our overall focus actually. One. So where we stand right now, I'll just a couple of minutes.
No, you can show it at the end. Let us start with the question answer.
Okay. Yeah, just a couple of minutes over, sir.
Okay.
Done. I'll show you so that people will. Can you see, sir? Can you see the screen now?
Yeah.
Okay. So this is what I have explained this. We have tied up with different institutes. Okay. So IIT Bombay, Bharati, COP, different areas we want to collaborate. And so we are in the process of signing the MOU. With IIT Bombay is done. COP is also yesterday we have met, and we are collaborating with sensors. Like that, different areas we are collaborating. And this is the drone I can show you. This is the drone we packaged with hydrogen fuel cell stack as well as with cylinders, and it will look like this. This is the present 25 kg drone, and this is the 75 kg drone. So we are planning to, this the design activity is done, and powering of drone is in the process. By made in flight, by January 24, we want to fly this first 25 kg drone. In March 24, we would like to fly the 75 kg drone. So this is our lab. This is the bipolar tools we have developed it, and this is the stack. This is the bipolar plate.
Yeah.
In this injection molding plant, in that plate we have generated. This is the tool. We have seen this. This is the tool for bipolar plate. So this is a BOP system. This is the hydrogen tank, compressor, coolant pump, and this is the plate, and this is gasket we have designed and developed right now, and we are integrating into the drone right now. So this is a membrane, and this is our office. Yeah, that's all, sir. Yes,
Thank
I'm
you.
ready for any questions
Yeah,
I can
thank
take.
you for your nice presentation and giving the information which is upcoming area. So now I request the participants to have their questions and doubts which they want to clear, or if you have any association required, you can also put up. I request Upendra ji to put your email address and phone number so that people will be in a position to contact you.
Yes, sir.
Anybody has any question? Anything to ask?
Hello.
Yeah.
Upendra ji, thank you very much for wonderful presentations. Very informative presentations in a very different area. And friends, question answer session is on now. So whatever the questions you want to ask, please ask Dr. Upendra. Please introduce yourself before asking the questions. So sir also will know who is asking the questions. Thank you very much. So questions, please.
So I just want to introduce Mr. Pankaj Kumar is also joined,
Okay.
and he can throw some light if any further questions are also there. Yeah.
Okay.
Yeah, good morning, all.
Pankaj Kumar. Yeah.
Good morning, Pankaj Kumar.
Good morning, sir. Good morning, everybody.
Yes, Shailesh ji. Yes.
Sir, I'm a chemical engineer. I studied in LIT. I worked in the CSR laboratory in Pune. I was initially in NCL, but now I am in a unit of patents, or what is we call it as a URDIP, Unit for Research and Development of Information Products. And at my place, we analyze the patents in the different domains of chemical, physical science, engineering science, as well as biological science. Now, CSR, I know internally have a big hydrogen cell or hydrogen fuel cell. I'm not very sure because I'm not involved in the projects, but there is a big initiative on that. But I have not seen the CSR collaboration. Any of the CSR laboratory has a collaboration with you, or means that is the question I was asking.
Yeah, we
Yeah.
are.
So
Yeah. Please continue, Pankaj.
So good morning, sir.
Yeah.
So I'm Pankaj Kumar.
Yeah.
We are the incubators of Venture Center, NCL Venture Center,
Okay, okay.
and yeah,
Yeah.
and we are in touch with Dr. Lele,
Okay,
and
okay.
I mean we have worked together for very long on the hydrogen fuel cells.
Okay.
Rather, we learned hydrogen fuel cell initially from the NCL itself. So yeah, so soon there will be some collaborations.
May I know, Mr. Pankaj Kumar, Dr. Pankaj Kumar is from the same company from where the speaker is?
Yeah,
Yes,
I'm
he's the
the
founder
founder and
member.
managing director of the company.
Okay, now what happened that I connected the webinar some 10-15 minutes late, and in
Yeah,
between the being Sunday, I could not really continue that, but I have seen some of the things basically. But
yeah,
it's better like if the speaker shares his email and all that.
yeah.
And you are based in
We are
like
based in Pune, sir. Yeah, we are based in Pune only.
yeah, but then
Yeah,
you must
and
be in a venture center. You must be very closely associated with Dr. Premnath and
yeah.
yeah.
Correct.
Okay.
Yeah,
Yeah, so then I think the collaboration is on basically that way.
Yes,
right.
Yeah,
yes.
okay, sir. Yeah,
So all the projects we are reporting to Dr. Premnath. I mean, we are updating, them with all the progress and all the things we
yeah.
are doing.
Yeah, I mean, so Dr. Premnath has established, as you know, everybody knows, a very good
Yes,
venture center and like startup ecosystems he has developed, means which is typically outside the CSR system in under the Section 25 company. We being the unit of the CSR headquarter attached things, we are more focused on the internal CSR projects and the technology monitoring in the way of patents. And as the volume of work, as you know, CSR is involved in too many projects and all that. So we are the small team of 10, 15, I think 12, not 10, not even 12. I think we are 9 scientists who are working in the different areas of like chemical science. We have two or three. Biological we have 2, 3. Engineering we have only 1. Physical also 1 or 2 scientists who basically like try to give this services internally. We also give services to the outside agencies also, of course through
Okay.
the a little understanding and MOU and all those type of things. We do give services to some of the
Okay.
foreign companies also under the like umbrella MOU
Shailesh
contracts.
sir, if you
Yeah.
share your email and mobile number, people will take it for their requirement. If anybody
Yeah,
has any,
basic. Yeah, I,
Yes,
I will
sir.
I will I will put up that thing in the chat box here. I can
Yes,
do
sir.
that.
Yeah.
yeah,
Yes.
yeah.
Yeah, basically, even though means I am there, but I am not directly associated. My other but that is the mandate of my unit. We are the small unit of 30 people, so we have the very focused thing. I will put up the things, but
Yeah.
I request the speaker to put
Yeah,
up his
sure, sir.
numbers also. Yeah.
Sure.
Okay. Yeah.
And I would like to share here one more thing. My name is
Yeah.
Chaitanya from Tech Forum.
Uh-huh.
We can take this subject carry forward on further to the industry with various one-to-one meeting or multiple meetings or group meetings or Zoom meetings. So Tech Forum is there with you to support you all these things. So we will discuss later on Tech Forum and also carry forward this topic to industry. Thank you, Shailesh sir, for updating.
Yeah. Okay. I am just putting up my details.
Yeah, Upendra sir has put his number. Participant, please note his number is there on a chat box. For just for understanding, I can read the number itself. Yeah, his number is 880-500-4061. The name of concerned person is Dr. Upendra Paluri.
Yes.
His email also Upendra AP, UPENDRAP at
Luxusfur.com. Yeah.
.com. Okay, friends, still
Anyone
5 minutes
has
time
any-
is there available for all of us.
Yeah.
You can shoot your questions and plus introduce in brief yourself and ask the questions. So we can take further questions.
Hi, good morning. Ashok here from Adweek.
Yes, sir.
Good morning, Upendra. Good morning, Upesh.
Yeah.
So actually, initially I could not attend this. So can you please elaborate on the size of, with respect to size between this hydrogen fuel cell and lithium PO4 battery and that energy density?
Okay. So you mean to say, can you repeat once again, Ashok ji?
No, actually, slightly I could get is that fuel cell is size-wise, fuel cell is having lower size
Right.
than LiPo4 battery. And
Right.
so with respect to energy density, can you please explain?
Yeah. So, normally, the battery for 1 kilowatt hour capacity is around 8 to 10 kg. So there, the hydrogen fuel cell, for the 1 kilowatt, will be for the drone applications. What we have developed will be weighing around 7 kg. So there, the per kilowatt energy density is like that. In terms of packaging size, in terms of dimensions, fuel cell for 1 kilowatt will be little bigger. I mean, it will be bigger by about 50 to 60%. But for the higher size, if you see the batteries, then if you double the capacity, I mean the energy of the battery, the battery size gets doubled. But in the case of fuel cell, when you double the energy capacity, then the fuel cell size doesn't double. It just increased by something like 20%. So there, for the higher kilowatt, fuel cell have the lesser energy density compared to the batteries.
So
And,
can you see this slide? Hello.
Yes, yes.
So yeah, this is what I was about to explain. Okay. So the fuel cell weight, the Pankaj has explained that one. Right now, the fuel cell is for a particular flight time, we are 25 kg. Weight is around 10 kg for a lipo battery, whereas fuel cell is 8 to 10 kg only. Okay. Suppose if you are going beyond 100 kg, the fuel cell will be around 15 kg only, whereas this will be 64 kg.
So which type of fuel cell you had considered here?
This is a PM fuel cell.
Okay, PM fuel cell.
This
Okay.
is the PM fuel cell, liquid cooled, and
It's a liquid cooled. Yes.
closed cathode.
Closed cathode, liquid cooled only.
Just to share some information, as I understand that CMCRI Bhavnagar has also developed certain PEM membrane. I don't know the exact status of the technology and effectiveness, but there are people, I will share the information with him. There is a person by name Khandekar, and he worked for them. He is a mechanical engineer, and he developed certain things for the membrane making machine. Just to share the information to the Upendra ji and Pankaj.
Pankaj.
Yes, yes. And
Okay.
is it a, I mean, is it a government laboratory or it is a private firm?
Sir, basically, anything related to CSR, if it is a CM, I think marine and salt chemicals, if it is there,
It is
yeah,
Okay,
then
okay.
it
it
is a
is a
lab like
CSR laboratory
yeah, it's a
Okay.
CSR like NCL.
Okay, okay.
Yeah,
Yes.
it's like NCL. The
working on
same,
electrochemical aspects of the chemical engineering.
sir, marine central CMERI, marine chemicals, sir. Basically, marine chemicals is the target for them.
Yeah, I know that institute.
So, sir, actually, I was interested in PM fuel cell working. So, if you would like to visit and see that, is it possible?
Yes, yes, of course it is possible. You're most welcome. By the third week of December, our drone will be available for the. I mean, the assembly will be done. Although the maiden flight is due in the month of January. So after the assembly, we'll be able to show you the complete operation of the fuel cell.
Yeah, thank you. Thank you, sir.
Sir, in Pune, where are you based?
Yeah,
We
based
are
in
based
Pimpli
in-
Nilak. Pimpli Nilak.
Pimpli near. Okay, nearby.
Yeah.
Nearby Pashan.
Yes.
Yeah, thank you.
Yeah, thank you, sir.
In continuation with this, I would like to share one more information, is that there will be down the, you want to ask question? Pratik, you want to ask the question? Hello?
Friends, there is 11 o'clock. We just passed 1 minute. This is the last question. Mr. Pratik Khare, if you are interested, kindly ask the question. Introduce yourself before asking question. Pratik Khare, please. Shailaji, you have raised the hand. Do you have anything to share with right now?
I want to lower my hand, but I'm not able to do
Okay.
it.
No,
in my mobile.
no
Don't worry.
problem. No
So
problem.
I will do that, sir.
Okay.
I'm doing that. Yeah.
Anilji, I want to share one information
Please share.
further, that on 14th of January, we have planned one more session in line with the similar kind of thing. There is a company who has developed the plants who will be manufacturing hydrogen, and that is by biomass, and they will be producing carbon black, and there is some kind of thing of buyback arrangement and things like that. So there is a humble request to join more and more on this platform, so that you people will get the latest information on what are the future technologies coming up and they are working.